Okay, so this is just a quick video to follow up on the concept of speeding up or slowing down, and specifically from a graph. So here we have a bunch of displacement time graphs here, and I want to look at whether the objects are speeding up or slowing down. And to do that, I would need to take a look at, is the velocity and acceleration positive, negative, or zero? Okay, so just taking a look at this first one, I hope that you can see that if I was to draw some tangent lines on this curve, hopefully you could see that all of the tangent lines would have a positive slope, which would mean that the velocity is positive. Okay, and then to look at acceleration, we're going to look at how the velocity is changing. So if I'm looking at the slopes of the tangent lines, I can see in this first one that it's a positive number. I like to put a number on it, like maybe a slope of 5. This one would be less steep, so maybe a slope of 3, and this one maybe a slope of 1. So the slopes of the tangents are decreasing, which would mean that the acceleration is negative. And because one's positive, one's negative, this would mean then that the object is slowing down. Okay, and hopefully we have that knowledge even from just physics, motion, distance times graphs. You kind of know that that's a deceleration graph. Okay, let's take a look at the next one. Similar idea, if I was to draw slopes of tangents, here I'm just drawing some tangent lines. Hopefully you can agree that all of the slopes of the tangents would be positive. Okay, and then let's take a look at how they are changing for the acceleration. Here I have a positive slope, maybe a number like 1. It's getting more steep, right? So maybe a number like 3 and 5. So the slopes of the tangents are increasing, which means that acceleration is positive. Both are the same, so that would mean speeding up. Both sides are the same, so this would be speeding up. So in this next one, I hope you can see that the velocity is positive because it is just going up, so the tangent line is positive, and of course the tangent line wouldn't be changing, right? So the acceleration is actually 0, and this represents the idea of constant speed. Okay, and in the next one, the velocity, of course, is negative. Again, slopes of tangents wouldn't be changing, and this one is also a constant speed. Okay, so pause the video and see if you can try the last one on your own, and if that makes sense to you. Okay, taking a look at the last one, you can see if I was to draw tangent lines, they would look something like this. Okay, we can see that they're tangent lines the slopes are negative, so the velocity is negative. And then looking at how the tangent lines are changing, again, I like to use numbers. This one would be maybe like -1. This one would be -3. This one's more steep, -5. So the slopes of the tangents, the values are actually decreasing, which means that the acceleration is negative. Both are the same sign, and so this would be the case of speeding up. Okay, and in this video, we'll do one more example where, of course, the important thing is to be able to read the question and make sure that we understand what to do. Okay, so we have the position of a particle. This time we're moving along a straight line. Okay, and here is the equation that represents the motion, the horizontal motion. And first question is, I'm asking you to find the velocity of the object after 2 and 5 seconds and the acceleration at these times as well. So hopefully you know what to do there. So pause the video and then just check your work to make sure that it is correct. Hopefully you got these numbers, and don't forget units there as well. And I do just want to add then, just taking a look at 2 seconds, okay, we can see that the velocity is 0, which means that the object is stopped, right, at that time. Not speeding up, not slowing down, stopped, regardless of what the acceleration is. Okay, and then at 5 seconds, we notice that both the velocity is positive and the acceleration is positive, and so both are the same sign. So here, the particle is, or object is speeding up as well. Okay, next question, we want to look at when does the object actually stop, okay, and we know this from last day, that this is when v at t equals 0, so we already have v at t from above. Of course, we need to set it equal to 0 and solve for t. You will notice that this factors nicely. Oh, sorry. t minus 3, and t minus 2. So t equals 2 and 3. Okay, therefore we know that the object is stopped at 2 and 3 seconds. And then the second part of the question asks, what is the object's position when stopped? Okay, so to find the position is s at t, so we can find s at 2, and we can find s at 3, and note its position when it stops. So go ahead and plug those numbers in, pause the video, and make sure then that you got the right answers. Okay, so at 2 seconds, you should get 36 units or meters, and at 3 seconds, 35 meters. Okay, and the last question, something that I just want to clarify, is this question is asking when the object is moving in a positive direction and a negative direction. Okay, so hopefully it makes sense to you that a positive direction would be when v at t is greater than 0, and a negative direction would be when v at t is less than 0. Okay, I hope this reminds you of when you were doing inequalities, polynomial inequalities back in advanced functions. And so to do this, we actually set up an interval table. Okay, and we're going to be using our v at t, which we have already in factored form above. Okay, and I make a large interval table. Technically, we even have a 6 in there. We have a t minus 3. We have a t minus 2. And that will provide us with the overall sign of v at t. You're welcome to just use the bottom row in this table if that's what you're used to. I usually just like to lay it out so that I don't need to use my calculator at all. Okay, and we know that when an object is stopped is when it's going to change directions. Okay, of course here we're working with positive numbers of t only for time, and then it stops at 2, so that would be my first interval. Then I would have the interval between 2 and 3 seconds. And then lastly, I would have the interval of greater than 3 seconds. Okay, and I'm just going to be plugging numbers in. So in this first column right here, I'm going to plug 1 into all of these and take a look at my signs. Obviously, this one's positive no matter what. This will be negative. This will be negative. Overall sign of all 3 would be positive. Okay, in the next column right here, I'm going to be plugging in 2.5 into all of these. Obviously, this is positive, this is still negative, but this one's now positive. Overall sign for all 3 would be a negative sign. And then in the last column, I'm going to plug in 4, and I get positive for all of them. Okay, so the object is moving in a positive direction up to 2 seconds, from 0 to 2 seconds, and after 3 seconds, and of course between 2 and 3 seconds, we can see that it is moving in a negative direction. So we'll just conclude there. And when t is greater than 3 seconds, and then we have a negative direction when t is between 2 and 3 seconds. Okay, so I hope that helps explain that, and now you will work on some practice.